Hi everyone, this is Xiaoqiu, Jiachen, and Siyu from the team AEIOU. Welcome to our presentation. Our goal is to build a system that reads in wiki documents and produce fluent and reasonable questions as well as correct and intelligent answers. Our presentation will go through the asking, answering, and reference. Let's come to the question asking part. First of all, for a good question asking system, we should solve the following questions. First is what kind of sentences can be used to generate questions. Second is what type of questions should we generate. Third is how we evaluate the quality of each questions. We also find the pre-process contributes a lot to the high performance of our QA system. We first filtered out too short or too long sentences from the input documents. Later on, we reformed the documents into a list of sentences and sent them to the next parsing API.
To make sure the sentence is reasonable, we propose three basic rules. First, the question should contain NP, VP, NP components. And second, preposition or phrase which appear at the beginning of a sentence will be deleted. At last, we delete all clauses in questions. To deal with second problem, we separate our questions into three parts: easy, medium, and hard. First, for easy question, we simplified auxiliary verb and put it at the beginning of the sentence. And second, there are two ways to generate medium question. One way is to use name entity recognizer to find people name. If the name appear at the beginning of a sentence, we directly replace such proper noun with who. Another way is to use pattern matching. The generating process for this question are similar. For word question, we're trying to find noun phrase at the beginning of a sentence. For one question, we will match date phrase in the sentence, such as in 1987. For hard question, we try to replace sentence components, such as date, location, and similar words. And at last, to deal with the third problem, we use the perplexity to evaluate sentence fluency and rank all possible questions. First, we train interpolation language model on training documents and question. And second, we use to generate EM algorithm to optimize model parameters. And finally, using the language model, we rank the questions based on complexity and pick questions in ascent order of complexity.
In the question answering part, since we have already known that the questions are generated from the given document, then the most important step is to find the sentence that is used to generate the given question. We call this step sentence matching. In sentence matching, both documents and questions will go through the feature extraction process, where the tokenization is used to cut the sentence into tokens, and the stemming comes to reduce the tokens to their stems. For the questions, the part of speech tagging assigns different weights to different word stem. This idea reads as we believe something like verb and adjectives may be more important. Finally, we apply bigram expansion to both question and the sentence to catch consecutive matching. Let's see an example. For sentence Peter loves NLP, we will generate features like Peter love NLP, Peter love and love NLP. While for question who love NLP, we will generate a few tuples that include the feature and the corresponding weight. After extracting features from sentence and documents, we can then match every sentence to each question and get the score, which is the sum over the weights of matched features. Finally, we can sort the scores for sentence and get the best matching one. Here we can see in our algorithm, the best matching sentence will generally have a high score over others. While in question answering, the first step is to extract question information such as question type and some useful grammatic structure. To do that, we need the parse tree for both question and best matching sentence, and the named entity tags for all the words, which are very useful for some tasks like answering questions starting with who. Let's draw an example. For sentence Peter finished the NLP class on May 5th, 2015. We can find the NP-VP structure with the named entity person, and also we can find some prepositional phrase which contain the dates. With this information in hand, we can go to answering the general question. And since the general question only requires an answer of yes or no, then the key idea is to check the information completeness and sequential consistency. The information completeness matters whether the information mentioned in question also appears in the best matching sentence. For example, in question did Peter finish the NLP class in 2015, we found the Peter finished NLP class and 2015 in the best matching sentence. So it is a perfect match and we say yes. For the sequential consistency, it checks whether the sequential information is changed. For example, in question did Peter think NLP was the most boring class? We compare with the best matching sentence and find a mismatch between interesting and boring. Since these two adjectives has opposite meanings, so we say no.
Okay. When catch up with some complicated questions, the key idea is to utilize information needs from name, entity tags, and the parse tree. We mainly use two approaches. First is to extract target grammatical structure. Second is to use sentence component. In approach 1 for this question, we first find NP-VP or similar grammatical structure in the sentence and find the entity tag in those structures. And in this example, we return Peter as the answer. In approach 2, we find all nodes with PP tag and rank all the candidate phrases with rules. Finally, return the time with highest score, say as shown in the example on May 5th. And this is our references. Thanks for watching. Have a nice day.